Welcome to a new lecture. So this is going to be lecture 3. Okay, so lecture 3, in last two lectures we have seen how to find Newton's force of attraction, gravitational force of attraction. Then we studied gravitational force field. Okay, so what is gravitational field? These things we studied. So if you haven't watched those lectures, you can go and it will be available there. So now third lecture will be on, it is about gravitational potential energy. So third lecture will be based upon gravitational potential energy. Okay. So to be simple, only one formula we have to learn. Okay, if there is a mass m and a small mass m is there, okay, and distance between them is r, so gravitational potential energy value for these masses means this system of two masses will be given as minus of g capital M by small m by r. Okay, so this you have to remember like this. But we are not only remembering here, I will also find how to find the gravitational potential energy when the system of masses is given. Okay, so we will do derivation also. So derivation, but through the derivation only one formula will get, and this will be the gmn by r. Okay, so for different system, if I introduce a third mass also, so you can write the gravitational potential energy between two masses, and then these two masses you can add them separately, and it is a simply you can add, it is a not a vector quantity, so you can add between these two and then these two and these two. Okay, so three masses, so three combination will be there, so three terms will be there in total potential energy of this system. Okay, so now we'll see what is gravitational potential energy and how we can find this. Okay, so first thing, as we know that gravitational force is a conservative force. Conservative means path independent. Means this force doesn't depend upon the path chosen, it will depend upon initial and final position only. Okay, so that is why it's conservative force. And through work energy theorem, if you remember work energy theorem, that is total change in kinetic energy is nothing but work done by conservative forces plus work done by non-conservative forces. Okay, so this is our work energy theorem, and through this, and okay, this if you remember, well and good, and work done by conservative forces, it can be it is actually minus of change in potential energy. Okay, so we will use this thing. Okay, and work done by all the conservative forces will be equal to change in potential energy. So here, which conservative force we have here? Gravitational force. Okay, that is conservative force. So we'll find gravitational force for this system, same thing we'll do, and then we will equate it to change in potential energy. So from change we can find potential energy. Okay, so let's start this thing. Now you can see there is a mass, the system. Okay, so a system I formed. Okay, so it is like question only. So there is a mass m is there and small mass m is there. Okay, so distance between these two I can take as a r vector actually. So this m mass, capital M mass, will attack this small mass in which direction? So force will be in this direction. Okay, and now what will happen if we have to take this charge, not mass, m mass, from A to B. Okay, so we are taking this mass from A to B. Okay, this mass m from A to B I am taking. So you can say this distance from distance of point A from capital M is RA, distance of B from capital M, it will be RB. Okay, so what we are doing work done. Okay, work done from A to B, so that will be F dot dr. Okay, F dot dr, and I will integrate because I am taking from A to B, so it will be A to B, this will be F dot dr. And what is the force here? So force will be gravitational force, that will be in this direction, and dr is small displacement. Okay, if I am displacing this by little dr, okay, this will be small displacement. Okay, so this is F dot dr, dot product. So F into dr, this will be cos of theta, and theta here you can see theta is 180, so angle between force and displacement, so this will be 180. And now I will write value of this all. Okay, now we will solve. Okay, so work done by taking this M mass from A to B will be F. What is the force value? So force value magnitude you can say G capital M by small m by if this is at any general distance r, so it will be r square. Okay, so I will put G capital M small m by r square, and cos theta will be, it is minus you can say cos theta is 180, so it will be minus 1. Okay, so minus I will take out A to B. Okay, and dr I will take like this. Okay, direction of work done will be negative. Okay, because of this cos theta I took negative. Okay, now what we have to do, work done from A to B I can find. Okay, now just magnitude we are finding. A to B means you can take Gm small m by r from here, and now you have to, first we have to integrate. Okay, so negative you can take out A to B dr. So this integration G capital M by small m, this will be minus 1 by r. Okay, from A to B. Okay, so you can take this minus to this inside bracket, so G small m by 1 by r d by a, so you will get Gm by 1 by upper limit by lower limit. Okay, so this value you will get. Okay, so this will be work done from A to B, G capital M by small m 1 by B minus 1 by A. Okay, so everyone can get this value. Now we know that this work done will be equal to change in potential energy, minus of change in potential energy. Okay, so we can find change in potential energy. This is change in potential energy. Okay, so how can I write? Change in potential energy will be minus G capital M by small m 1 by B minus 1 by A. Okay, and actually I am writing A and B, so this is RA and RB everywhere. Okay, RA and RB. Okay, so you can change, means RA to be RA RB. Okay, everywhere. So this is you can say this is RB minus RA. Okay, so distance of B point minus distance of A point. So you can say that UB minus UA, final minus initial will be equal to minus of work done, and this will be minus can be adjusted, it will be RA minus RB. Okay, so this will be your change in potential energy. Now one thing we all must remember, that potential energy is every time we are talking about change in potential energy, we don't talk about fixed potential energy, because for potential energy we can only find change. Okay, and for potential energy we have to take some reference point, then only you can find the potential energy, exact potential energy. So what I am going to take, at r equal to infinity I am going to take u at infinity will be 0. Okay, this is my reference point. Okay, so now I can say that if I am taking that same particle, okay, you can say from A to infinity. Okay, or I can show it here. If this is a capital M, this is a small m, this is some a point, and I am taking this to infinity, from a to infinity. I am moving this particle from a to infinity. So u at infinity minus u at a will be g capital M small m 1 by r at a minus 1 by r infinity. So this term we can take it close to 0. Okay, so then I will say u at infinity will be 0, because I assume this is my reference point. Okay, so this will be 0 minus u at a equal to g capital M by small m 1 by r a. So again u at a will be g m m by r a, and this minus will come here. Okay, so see the derivation we got. So the potential energy at point A will be g m by small m by r, because of this mass system. Okay, or in simple term you can say u at any general distance r will be g m m by r. Okay, so this you can remember always, and don't forget this negative sign. Okay, so this will show you that it will be negative. Okay, potential energy. Okay, so now I think we are ready. And one thing also you can remember, change in potential energy will be always work done by external force. Okay, so this is must remember, you have to remember this. Okay, now we can go for further question. And in starting of this lecture I already told you, you can remember only this thing. Okay, u at any r will be gm by r. Okay, so this derivation I hope you get how we are doing. Okay, so now we will see some question where we have to find potential energy of this system. Okay. So similarly, if I'll take same question, okay, like 2 particle system we talk. If I'll take 3 particle, let me draw a triangle. Okay, so if I'll take okay, so 3 particle system. Now each particle is m1, m2, m3, sorry, m3, and I have given this side length as a. Okay, so what will be potential energy of this system? Okay, so to find potential energy we will take single charge. If you take these two pair, what will be its energy? Or you can name this is okay, capital A, or 1 2 3, you can say this is 1 2 3. So potential energy between 1 and 2 will be g minus g m1 m2 by a. Okay, potential energy between 1 and 3 will be minus g m1 m3 by a. Potential energy between 2 and 3, so this will be g m2 m3 by a. Okay, so this is u between 1 and 2, this is u between 1 and 3, this is u between 2 and 3. Okay, so you have to add them all. Okay, so it will be same. So here m1 and m2 are different. If m1 equal to m2 equal to m3, you could have written total potential energy will be 3 times of minus g m square by a. Okay, so that you could have written. Okay, so these kind of question. Same thing I can do it for rectangle. If I'll give you rectangle like this, 1 second, I can make a perfect rectangle. So where to go with this? Okay, so if I'll give you rectangle, okay, same, if mass m, this is l. Okay, so square you can take, this is m. So similarly you can find between these two how many pairs will form. So 1 pair, 2nd pair, 3rd pair, 4th pair, 5. So how many you have to write? So here actually you have to consider all the interactions. So u will be 4 times of between these two, 1 2 3 and 4. So 4 times of minus g m square by l. Okay, plus now between this and this there will be gravitational potential energy. Between this and this it will be, so you can say 2 times plus 2 times of minus g m square by what is distance between diagonal. Okay, so diagonal will be root 2 l, or what L is given. Okay, so this will be the potential energy of this system. Okay, I hope you got it, how to do find potential energy. Okay, for each combination you have to find. Okay, so you can take screenshot of this. If you have doubt, you can ask me in comment section.